What advantages does LLDB offer over GDB? Imagine debugging your code with a tool that feels more like an extension of your development environment. That's what LLDB aims to do. If you're working with modern programming languages or on Apple platforms, you might wonder how it stacks up against the traditional GNU debugger, or GDB. Well, let's explore what makes LLDB stand out and why many developers prefer it today. First off, LLDB is built as part of the LLVM project, which means it has a modern, modular architecture. This design makes it faster and more responsive, especially when debugging large or complex programs. It's optimized for newer languages like C++, Objective-C, and Swift, which are common in today's software development. GDB, on the other hand, was created decades ago and has a more monolithic structure, which can sometimes slow things down with big code bases. Another key advantage is how LLDB handles modern C++ features. It offers better support for complex data types, templates, and namespaces. This means debugging modern C++ code is smoother and less frustrating. GDB can struggle with these features, especially in newer compiler versions. LLDB's compatibility with Clang, Apple's main compiler, also improves debugging accuracy and performance on Apple devices. LLDB also provides a more user-friendly Python application programming interface. This allows developers to write custom scripts easily, automating repetitive tasks or creating tailored debugging workflows. GDB has its own scripting capabilities, but LLDB's API is more modern and easier to work with, making customization more accessible. The command syntax in LLDB is similar to GDB, but it offers more flexibility and easier-to-remember aliases. It supports shorter command abbreviations and GDB compatibility commands, easing the transition if you're switching from GDB. This means less time learning new commands and more time fixing bugs. If you develop on Apple platforms, LLDB is the default debugger for macOS and iOS. It integrates seamlessly with Xcode and supports Objective-C and Swift very well. This deep integration makes debugging on Apple devices more straightforward and efficient. GDB can be used on these platforms but often requires extra setup and isn't as tightly integrated. Thread and process management are also improved in LLDB. It offers clearer commands for switching between threads and viewing their status. This is especially helpful when debugging multi-threaded applications, where understanding concurrency issues is critical. GDB has similar features but sometimes feels less intuitive. Source path remapping is another feature that sets LLDB apart. It allows you to adjust source file locations during debugging, which is useful if your code was built on a different machine or environment. This flexibility helps maintain accurate source code views, even when paths differ. GDB has some support for this but isn't as robust. Finally, LLDB works well with modern integrated development environments like Xcode and Android Studio. Its graphical interfaces and advanced features make debugging more visual and easier to manage. It also performs better with large code bases, reducing lag and making your debugging sessions smoother. In essence, LLDB offers a modern, faster, and more adaptable debugging experience. Its support for current languages, better platform integration, and customizable scripting make it a strong choice for many developers. While GDB remains a reliable tool for many projects, LLDB's design aligns more closely with today's software development needs.